Alright, this is Jeremy Dauer presenting for my Chemistry Honors Final Deliverable. So the equation I chose was copper plus nitric acid reacts to produce copper nitrate plus nitrogen dioxide plus water. And balanced it's Cu plus 4HNO3 reacts to produce CuNO32 plus 2NO2 plus 2H2O. Oh, and I included a short video of my reaction, which I found on the internet. So when the reaction begins, a bunch of gas is produced. That's the nitrogen dioxide, I believe. And it comes up, out, and what's left is this really bright blue color. I thought it was really cool. Yep, there it is. So this reaction is actually not very useful because it doesn't really produce anything useful. And its main use is as a demonstration in labs because the blue color produced was really cool and people like to see it. It's kind of a show-off thing. The properties of the reactant. So copper, Cu, is a metal commonly used in architecture and wires. HNO3, nitric acid, is a highly corrosive acid used in rocket fuel and fertilizers. CuNO32, or copper nitrate, is used occasionally as a catalyst in organic chemistry. NO2, nitrogen dioxide, is a pollutant. It's used mainly in producing nitric acid. H2O is water. It is necessary for life on Earth, and its main use is as a refreshing beverage. So here's how to balance the equation and why we balance equations. So the law of conservation of matter says that matter cannot be created or destroyed. So when we put a certain number of atoms into an equation, we have to get the same number out, or else matter would have been created or destroyed, and that can't happen. So both the reactants and the products must have the same amount of chemicals. The unbalanced equation would be copper plus nitric acid reacts to produce CuNO32 plus nitrogen dioxide plus H2O. And to start balancing it, we would add a 4 to the nitric acid. A good way to start balancing your equation is just add a coefficient to the largest compound, and then just make everything else add up. And you can see here we add 2 to nitrogen dioxide and water. And this is the final balanced equation. You can see in the chart down here, there's 1 copper, 4 hydrogen, 4 nitrogen, 12 oxygen. It all adds up. The balanced equation is Cu plus 4HNO3 reacts to produce CuNO32 plus 2NO2 plus 2H2O. And now for limiting reactants. So the problem is 15 moles of copper react with 10 moles of nitric acid. First of all, what is limiting reactant, and how many moles of CuNO32 would be produced by this reaction? So to start, we need to find our limiting reactant. And to do that, we take both of the reactants and we do a little math. We multiply copper times the nitric acid and divide it by the amount of copper in the equation. And that tells us we would need 60 moles of nitric acid. However, we only have 10 moles of nitric acid in the equation. So that means nitric acid is going to be our limiting reactant. Now, how many moles of CuNO32 would be produced by this reaction? To find out, we need to take the limiting reactant and multiply it by the unknown, or what we're trying to find, and then divide it by the amount of the given reactant. So it'll be 10 times 1 divided by 4, and that tells us when 15 moles of copper react with 10 moles of nitric acid, 2.5 moles of CuNO32 are produced. And that's my final slide for my chemistry honors project. Thank you for listening.